Okay, so I'm Matt Grainger, postdoctoral fellow here at NINA, and I'm going to talk about LivingNorwayR. So LivingNorwayR is our companion package for the Living Norway project. It's still in development, but we want to introduce you to it here and maybe get some feedback on what we can do and what you want. As ecologists, we tend to have a workflow that's represented by this schematic. So me, I'm interested in pheasants and peafowl. So I go with my binoculars, I go watch some peafowl. I come back to my office and I start to put in my data. Within my computer, I might do my modeling and then do some graphics. Write that up as a paper, and then I push that out over to here to be published somewhere, hopefully. That journal I work for might want me to, the journal I submit to might want me to share my data. So I could go back to my computer, spend hours working out which version I used and all this sort of things, reformat my data, put it on some sort of server, Dryad, Figshare, whatever. More often than not, some of us might even just put this little statement in the end of our paper saying data available on reasonable request, and hope and pray that no one ever asks you for that data. But there's people around the world who do ask for data. They're after open science, open data, and this tweet here is someone talking about how that interaction goes. Them, you ask for some data, it's a reasonable request. Sorry, I can't give you that data. So this happens quite a lot. I'm very interested in code and code sharing. So early this year, there was a paper in Nature, a very interesting paper. I wanted to find the code so I could recreate their analysis. When I looked at the data availability and the code availability statements at the bottom here, what they say is that there is code available, but that code is actually the packages that I just make the things. It's not actually their code. It's just the package they used, which is not very useful for recreating someone's data. It's not reproducible. Erlen mentioned a few papers that have come out recently. This one's very recent, and you can see that actually we are sharing data. So we're doing well. Of 346 papers they looked at, 80% of them, roughly, had shared data. When you look at the code, it's less good, but it is improving slightly. So about 30 or 40% of the code is being shared. However, all the data might not be complete. So from another publication from 2015, they looked at the top-ranked journals in ecology and evolution, and they looked at what data was being shared. So they looked at the papers, and they found that only half of the papers they looked at shared all of the data from the analysis that they'd done in the paper. So this plot here just is on a scale of 1 to 5. So 5 being very good, everything's shared, everything's there. 1 being rubbish. Even when the data is shared, sometimes you can't reuse it. There's lots of reasons for this. It could be that it's using, it's just a photograph, an image of the data. That's something that often happens. So you can't reuse the data. You can't make use of it. So even though it's being shared, it's fundamentally useless. So I just have to change over. So this is results of a survey from Wiley in 2014. And it asked the question, what are the barriers to sharing data to different researchers across the world? And I've put them into these boxes, or circles, of different sizes. The size represents the number of people who responded. And I've put them into different categories. One's in society, so things that we as a society have to deal with. I can zoom in there. So it's things like concerns about confidentiality, concerns about ethics, perhaps. People worry about being scooped, so having their data used and their famous paper being taken away from them because someone else does it quickly. Misuse is obviously something that people worry about. Lack of funds, and it's not required. there's a couple of things I put into this researcher box. So these are things that the researchers might have to deal with. Data's not interesting. So if your data's not interesting to you, then why would it be to me? But we can still share it. And not my job. I think that's an interesting one because a lot of our data we work with, is publicly funded. And I think it probably is our job to be sharing this data. It's not ours to keep all the time. There's a couple of these things, though, quite a big proportion that Living Norway and LivingNorwayR can help deal with. So here, we can help to deal with where to share your data. We've spoken about GBIF this morning, that's one option. How to share your data, so that's something I'll talk about now. Having no time, so finding ways to actually integrate sharing data within our workflows. Okay, so it's not an extra task we have to do. And improper credit. Doug just talked about the citation process for GBIF. So that's something we can use to improve our data sharing and help us get benefit from it. This is the future. This is the future we envisage for Living Norway and LivingNorwayR. So this is our workflow. So again, I've gone out and surveyed my peafowl or my pheasants. I've come back to my office, to my computer, and then I've looked at, I've entered the data. But this time what I do is I curate, in that orange box, an archive. Now that archive can sit on your computer, it doesn't have to be shared, but eventually it will be shared if you want. But that archive, what we can do is then use that, a fixed, non-changeable data set that you can call back into your working environment and do your modeling and your analysis, and also some aspects of writing up your data as well, which I'll show you in a minute. And then we can send that all off to a publisher. So here we go for the LivingNorwayR package. The idea is it's an R package designed to facilitate that workflow and help people, make things easier. The main features we're going to have, or have already, importing and exporting Darwin Core archive files, mapping data to the Darwin Core terms. There's some R packages that allow you to map your data to Darwin Core terms, but they're quite difficult to get used to, almost impossible sometimes. And we want to make that process a lot easier, smoother. Automatic metadata extraction and writing functions. We're going to have those, so all the metadata aspects that you want, we can just pull straight from your data set. Some plotting functions, but also some modeling functions. Okay. So to help people integrate this whole thing into their workflow. So I'm going to give you a quick example of some of this, and there is R code, I'm sorry. But here we're going to talk about one of Erland's data sets on rock ptarmigan. So we've downloaded this data set from GBIF. It's publicly available, and there's the DOI to it. It comes from a publication, the paper's linked there. We also have some of the code for recreating the analysis in that publication is available on the Open Science Framework, OSF. So I used this data, I downloaded it a couple of days ago, and ran it through the workflow in Living Norway. The first step in Living Norway is to set up your data package. So this is a set of files where your project you're working your project from. And in that data package, you've got several different folders, let's say. The first one is going to be your data. So you've got a place to put your raw data. Any scans, any extra data you might have, so things that come from the field. So if you've written handwritten field notes, you could scan those and put them up. But also some derived data, so anything that you have to do some coding to adjust your data, log transform, whatever it might be. Some extra things go on there. You can save it all in there. Got a data management plan, this DMP in there. Let's move that down. some metadata. And the metadata is important because that's in three formats. One is the XML metadata, which is computer readable. There'll be an RMD, so a markdown file, which you can also read as a human. And then there's also this file which actually tells GBIF which files relate to each other in the end. Okay. And then you can also put in your scripts, your analysis scripts, in the folder somewhere. Okay, so that's the structure of the folder. We're using object-oriented programming, so it's a new one for me. So Joe's been doing a lot of this work here. What it allows us to do is create an object that is in R, that is a representation of one of these Darwin core main terms, these things. So we have this, for example, an occurrence data set, and we can map our occurrences from our raw data directly onto the Darwin core terms that are used. And if, like me, you're not used to the Darwin core terms, Joe's written some brilliant code to get us actually almost like a glossary of terms. So if you don't know what the term means, you can put in some code and it'll output what the term means. So here, an occurrence is an existence of an organism at a particular place or time. Okay. So for each different type of term, you can search the terms and get an output of examples, where you can find where that term was defined, and how it's defined, and any updates that happen to it. With these objects, you can actually make use of the data in the same way you would do as you would do normally using a data frame. So you can actually export a part of this object, the raw data that you want to use, or the data you want to use, as an object. Okay? So for example, if you want to do simple things like summarizing the data, so here I've just got this rock ptarmigan data set, and I'm summarizing the sex. So up here, I'm making it exporting a data frame from the object, and then I can use that to do other things. Also, with these object-oriented, we can actually embed functions within our objects. And that allows us to then, it's neater and easier to have that. So we can, for example, if you want to get the bounding box, so the geographical extent of the data set, you can just type in rock with a $ get bounding box, and it outputs the bounding box for you. Okay? So that will go into your metadata. Making maps is made quite easy. You just use the function plot map, and it gives you, in this case, the leaflet map, but we can change that to ggplot or whatever map you would like. So by using the object, it just calls up the underlying data and plots out the map for you. There's a few extra things we can add to this, but it's really what people would need. So we need to know what you want to add to. We're quite early on the stage of development here with the metadata, but we're starting to build an object, which is a metadata object. We can use that to either call in from a already published Darwin Core archive on GBIF, or we can create our own. What it allows you to do is to get the information, that metadata information, from the Darwin Core archive, and you can use that in some way. So here, it's not very neat at the moment, but we call out for the abstract, we get the abstract of the data set in. And you can use that in your RMD file, so your markdown file, or in your report, whatever you want to do. Then you can do some analysis. So all within the same object, you can do some analysis. Okay? So here, because of occurrence data, it's often things like survival we might be interested in. We've got this function for running a survival model. Yeah. This is still very much in development, but we can run a survival model and output to you the survival. And we can add a plot to that as well, if you want to. So this is one of the things I'm quite excited by. So we can start to have ways to help you write up standardized results. this is particularly helpful for things like working with monitoring reports, annual reports, where you have the same basic structure. We can embed our code into Markdown files that allows us to pull out those key bits. So we can have templates that will allow you to write up your data for those structured areas, particularly for certain analyses. This just shows what it looks like to the human at the top. As you're all humans, you'll see that. And then below there, there's the results under the covers, which is the R code that goes into that. Okay. So finally, we're still in development, and we really want you to tell us what you need and what you'd like from us. So there's 3 ways to do this. The first is put up an issue on GitHub and tell us what sort of features you'd like to have. The second is to contact us over the next couple of days on Slack. So it's either Joe, myself, or Erland you can contact, and we'll try and add those as issues later on. Or you can just email me, old-fashioned. Pigeon post might work too. So thank you very much, and hope you enjoy the rest of the colloquy room.
In the meantime, we do have a question. We have time for a question, so let's see, there came in a question just now. Are there plans to support Darwin Core extensions for sequencing data like Mixes extensions in LivingNorwayR in the future?
Yes, there's lots of plans for the extensions, and it's something we're looking at. At the moment, it's just in development, and we can let you know how that goes.
And then there is another one. R code is very useful as the underlying code, but in most cases it does not work to ask researchers to enter metadata in an R script. Do you have a front end to enter, edit, check the metadata and its consistency with the data?
Soon. That's one of the things I'm working on now. We're trying to get that to work, to make it a lot easier for that process. If anyone has data they would like me to test for them, that would be wonderful as well.
Thank you.